Next one, coupled questions with the pyrolytic sin elimination. Coupled questions with the pyrolytic sin elimination. Pyrolytic sin elimination, that is EI elimination. The detailed aspects of pyrolytic sin elimination that we will discuss in the reaction mechanism section. Okay, detailed aspects of pyrolytic sin elimination in reaction mechanism. Okay, so what is pyrolytic sin elimination, EI? Elimination reaction. Four mechanisms are proposed. First one, E1 mechanism. Second one, E2 mechanism. Third one, E1CB mechanism. E1CB, conjugate base mechanism. And fourth one, EI mechanism. These are the four mechanisms of elimination. Okay, E1, E2, E1CB, E1 conjugate base mechanism, and EI. Details we will study in the reaction mechanism section. Okay, so simply I will say you what is E1, what is E1, what is E2, what is E1CB, what is EI. Okay, in E1 mechanism, here a group X is present. This X is a leaving group. And here a hydrogen is present. Hydrogen. In E1 reaction is a two-step process. E1 reaction like SN1 and SN2. E1 is a two-step process. In the first step, this leaving group is eliminated. X minus is eliminated. To form a carbocation. In the next step, this carbon hydrogen bond shifted towards this side to form an alkene. So an alkene is formed. After elimination, multiple bond is formed. An alkene is formed. So E1 elimination is a two-step process. Elimination is a two-step process. First step is the elimination of leaving group X minus to form a carbocation. Next step, proton carbon hydrogen bond is subtracted to form an alkene. Then second one, E2 elimination. In E2 elimination, suppose this X is the leaving group and this is the hydrogen. Okay, E2 elimination is concerted. That means single step reaction. E2 elimination is single step reaction. That means this bond is shifted towards this side. At the same time, this halogen is eliminated. So in one step, an alkene is formed. Okay, so E2 elimination is single step reaction. Third one, E1CB. In E1CB elimination, here X is the leaving group and here a hydrogen is present. In the first step, a base. What is the function of base? Abstraction of proton. Base will abstract a proton to form a carbanion. Instead of carbocation, a carbanion is formed. In the next step, what happens? This negative charge will make a pi bond here. This leaving group is eliminated. So that is E1CB. Okay. So E1, E2, E1CB. In E1 elimination, first step is the dissociation of the leaving group to form a carbocation. Then elimination of H plus to form alkene. In E2 concerted elimination of halogen and H plus both takes place in concerted manner, single step reaction. In E1CB, elimination by conjugate base formation. First step is the formation of a conjugate base or carbanion. Second step is the elimination of leaving group. In pyrolytic sin elimination, fourth one is pyrolytic sin elimination. Pyrolytic sin elimination. What is the difference? It is sin elimination. That means the group X and hydrogen are on same side. The group X and hydrogen are on same side. Okay, in EI mechanism, that is a syn elimination, the X group and the hydrogen are on same side. This hydrogen is the beta hydrogen. This is alpha, beta. So you have to consider the beta hydrogen. So this X group are having lone pair or negative charge. This lone pair or negative charge will interact with the hydrogen. At the same time, this bond will shift towards this alpha beta position. Then X minus is eliminated. So what is the product? An alkene plus XH. An alkene plus XH. That is the product formed. This is called as pyrolytic syn elimination. So how pyrolytic syn elimination takes place? Your X group will interact with the beta hydrogen. This carbon hydrogen bond shifts towards this alpha beta position. Then X is also eliminated. Okay, so in all elimination, an alkene is formed. Here we have to discuss about this pyrolytic syn elimination, which is very, very, very important. So what is pyrolytic syn elimination? Pyrolytic syn elimination. Okay. First one, what are the compounds which shows pyrolytic syn elimination? Compounds which shows pyrolytic syn elimination. Okay, first compound, sulfur and selenium oxide. Sulfur and selenium oxides. Okay, sulfur and selenium oxide. For example, this is a sulfur oxide, S double bond O pH. This compound will show pyrolytic syn elimination. Okay, then next one, selenium oxide, Sc double bond O pH. So sulfur and selenium oxide show pyrolytic syn elimination. Second one, ester. What is the formula of ester? O C double bond O CH3 or R. This is the ester. O C double bond O CH3. This ester will also show pyrolytic syn elimination. Then next compound, nitrogen oxide. That is N coordinate bond O CH3. So these are the four typical compounds that shows pyrolytic syn elimination, a favorite question of CSIR NET and GATE exam. Okay, I will explain the pyrolytic syn elimination. First of all, you have to understand what are the systems that shows pyrolytic syn elimination. First one, sulfur oxide, S double bond O. Then selenium oxide. Then nitrogen oxide. Okay, then ester, OC double bond O CH3. So these are the systems that shows pyrolytic syn elimination. Then some examples. For example, the first one, a sulfur oxide, S double bond O pH on heating. Under thermal condition, elimination takes place under thermal condition. That is why it is called as pyrolytic syn elimination. Okay, pyrolytic syn elimination. Since it is a syn elimination, I can represent this compound in this fashion also. This is the bond. Here sulfur, pH, S double bond O can be written as O minus and S plus. O minus and S plus. Here consider the beta hydrogen. This is the alpha carbon. This is the beta carbon. In this beta carbon containing a hydrogen. Beta carbon containing a hydrogen. So this hydrogen is eliminated. This O minus will interact with this hydrogen. This bond will shift towards this alpha beta side. This is moved to the sulfur. So under thermal condition, what is the product? Elimination on heating. That is why pyrolytic elimination. So an alkene is formed. An alkene is formed. Plus byproduct is PH, SOH. PH, SOH is the product. PH, SOH. Okay. So that is a byproduct. Then next example, a selenium oxide. Sometimes in your question paper, selenium oxide is given in this fashion: PH, SC, double bond O, PH. SC double bond O, PH. You have to written in this fashion: bond, SC, PH, O minus, selenium plus. Then consider the beta hydrogen. This is alpha carbon, beta carbon, and this is the beta hydrogen. This O minus will interact with the beta hydrogen. This bond make a pi bond here, and this is eliminated. This SC group is eliminated. So what is the product? Elimination, pyrolytic elimination. A double bond alkene plus PH, SC, OH. PH, SC, OH is the byproduct. So here also an alkene is formed. Okay. Then a nitrogen oxide. Third example, a nitrogen oxide. Third example, NCH3 O minus N plus. A nitrogen oxide is given. What is the reaction? Consider the beta hydrogen. This is the beta hydrogen. This O minus will interact with the beta hydrogen. This bond is shifted towards here. This group is eliminated. So under thermal condition, you will get the product, an alkene plus the byproduct. Byproduct is NCH3 OH. NCH3 OH is the byproduct. Then fourth example, an ester. Ester is C double bond O CH3. C double bond O CH3. Okay. Here the elimination is, this oxygen containing lone pair. So this oxygen will make a pi bond here. This will interact with this beta hydrogen. Here a beta hydrogen is present, interact with this beta hydrogen. At the same time, this bond will shift towards this alpha beta side, and this is eliminated. So what is the product? Under thermal condition? A double bond alkene is your product. Then CH3 C double bond OH. CH3 C double bond OH. C double bond OH is your product. Okay. So there also an alkene. So ester also undergo pyrolytic elimination. Our ester also undergo pyrolytic elimination. Then so we discussed the pyrolytic elimination of sulfur oxide, selenium oxide, then nitrogen oxide and ester. Then another example, fifth one, a ring system. Here SC, PH, O minus, selenium plus. Okay, so here also selenium oxide. What is the reaction? You have to consider the beta carbon. This is alpha carbon and beta carbon. In beta carbon, a hydrogen is present. This O minus will interact with the beta hydrogen. This bond will shift towards this side. and the selenium group is eliminated. So under thermal condition, pyrolytic elimination takes place to form an alkene plus byproduct PH SCOH. PH SCOH. Clear? Then sixth example, a ring. Here N CH3 coordinate bond O. Coordinate bond O means nitrogen plus O minus. You have to consider the beta hydrogen. This is alpha, this is beta. This beta carbon containing a hydrogen. This O minus will interact with the beta hydrogen. This bond will shift towards this side. This group is eliminated. So under thermal condition, pyrolytic elimination will take place to form an alkene is your product. Then next example. For a pyrolytic elimination. A 5-membered ring SCO minus plus pH. SCO minus plus pH. Under thermal condition is thermal. Definitely this is a selenium oxide compound. Under thermal condition, selenium oxide, nitrogen oxide, sulfur oxide and ester. Under thermal condition undergo pyrolytic elimination. You have to consider the beta hydrogen. This is alpha, this is beta, and this beta carbon contains a hydrogen. So this O minus will interact with the beta hydrogen. This bond will shift towards this side, and the selenium is eliminated. So what is the product? A 5-membered ring. Here 1, 2, 3 carbon. 1, 2, 3 carbon. Okay, 1, 2, 3 carbon. Between 2 and 3 a pi bond. So that is the product. Okay. So beta elimination. Beta hydrogen is always eliminated. So we discussed some basic facts of pyrolytic syn elimination and the system which shows pyrolytic syn elimination. Now we are moving to pericyclic, some coupled question of Diels-Alder reaction with the pyrolytic syn elimination. Okay, some coupled question of Diels-Alder reaction with the pyrolytic syn elimination. First question, a diene is given. Plus a compound SC double bond O pH. Under thermal condition. So diene is there, thermal condition is there, but there is no dienophile. Where is the dienophile? That is my question. Where is the dienophile? Then how will you identify that this is a Diels-Alder reaction? A diene is there, a thermal condition is there, but dienophile is not there. Instead of that, a condition for the formation of dienophile is given. A selenium oxide under thermal condition, definitely pyrolytic syn elimination. Okay, pyrolytic syn elimination is EI. Pyrolytic syn elimination. So our selenium oxide that can be written in this fashion: SCPHO minus under thermal condition. Pyrolytic syn elimination. Okay, alpha carbon, beta carbon, and this is the beta hydrogen. O minus will interact with this hydrogen. This bond shifted towards this side, and this selenium is eliminated. So that you will get a carbon ethene is obtained. So this is your dienophile. So in the first step, that is a generation of dienophile. Then only cycloaddition reaction, Diels-Alder reaction. So dienophile is generated. Then in the next step, your diene, that is 1,3-butadiene, simply react with the formed dienophile to form a 4+2 cycloaddition reaction under thermal condition. This is a 4+2 cycloaddition reaction to form a cyclic product. So simply this is a 4+2 cycloaddition reaction. Diene is there, but there is no dienophile. But you know, when sulfur oxide, selenium oxide, ester, nitrogen oxide under thermal condition undergo pyrolytic syn elimination to form an alkene. Pyrolytic syn elimination to form an alkene. Clear? That is also a coupled question. Then question number 2. Question number 2. A diene is there, an exodiene plus NOCH3CH3 under thermal condition. What is the product? Diene is there, but there is no dienophile. Diene is there, but there is no dienophile. But the condition for the formation of dienophile is there. A nitrogen oxide under thermal condition undergo pyrolytic syn elimination, EI. Pyrolytic syn elimination, EI. So your nitrogen oxide can be written in this fraction, NCH3, CH3. This is N plus O minus. Consider the beta hydrogen. This is alpha carbon, beta carbon, and this is the beta hydrogen. O minus will interact with this beta hydrogen. This bond is shifted towards this side, and this N plus group is eliminated, so that you will get a diene. In the first step, formation of not diene, dienophile. Formation of dienophile. Then in the second step, you have the diene. Then in the second step, you have the diene. This is the diene on reaction with the formed dienophile. The formed dienophile to form a 4+2 cycloaddition reaction. 4+2 cycloaddition reaction. So this ring as such, then a new 6-membered ring with a double bond is formed. So that is your product. Clear? So this type of question, a favorite question of latest CSIR exam, pyrolytic syn elimination. Okay, then moving to the third question. Plus OAC under thermal condition. Plus OAC under thermal condition. There is no diene. Diene is not there. There is no dienophile. Dienophile is not there. But the condition for the formation of diene and dienophile is given in the question. Okay, this is the method of asking question in CSIR NET exam in organic chemistry. Diene is not directly given. This is, but you can form a diene by electrocyclic ring opening reaction. Dienophile is not given. This is an ester. OAC is an ester. OC double bond O CH3. It's an ester. Ester undergo pyrolytic syn elimination under thermal condition. So both diene and dienophile can be generated. So first generation of diene. Generation of, my question, how you identify this is a 4+2 Diels-Alder reaction? Only by practice. Practicing many questions, then only you get an idea. Okay. So first step, generation of diene. Okay. So here a diene is generated. Okay. So generation of diene. This is the reactant. A strained ring system under thermal condition, electrocyclic ring opening reaction to form the diene. Okay. So a diene is generated. Second step, generation of dienophile. Generation of dienophile. Generation of dienophile. How we can generate a dienophile? How we can generate a dienophile? Here ester is there. Ester is CH3 O, C double bond O, CH3. This is OAC group. OAC is CH3CO. So that is the OAC group. Under thermal condition, what type of reaction? Pyrolytic syn elimination. This is the alpha carbon, beta carbon. This beta carbon containing a hydrogen. The lone pair on oxygen shifted towards this side. This bond shifted towards the hydrogen. This will make a pi bond here and that is eliminated. Circulation of electron. So that you get a diene. So in the first step, from this electrocyclic ring opening reaction. Electrocyclic ring opening to form a diene. Then ester. This is an ester. Ester under thermal condition undergo pyrolytic syn elimination to form a dienophile. Then easy reaction. How you can write the product? How you can write the product? That is my question. Diene is there. Diene is there plus dienophile is there. Under thermal condition, simply a 4+2 cycloaddition reaction. Simply a 4+2 cycloaddition reaction. So a 6-membered ring, then another 6-membered ring. Here a double bond. So that is the product. Okay. Sorry, here also a bond is there. Okay. So that is the product formed. Okay. Then next question. Fourth question. Fourth question. A diene is directly given. Diene is directly given plus Sc double bond O pH under thermal condition. A diene is given Sc double bond O pH under thermal condition. Right? What is the product formed? What is the product formed? That is my question. Diene is there, but there is no dienophile. But the condition for the formation of dienophile is given. Selenium oxide under thermal condition. So pyrolytic syn elimination takes place. Pyrolytic syn elimination. This selenium pH double bond O can be written as O minus selenium plus. Then consider the beta hydrogen. This is alpha, this is beta. Beta carbon containing a hydrogen. O minus will interact with this hydrogen. Here a pi bond. The selenium group is eliminated so that you get a dienophile. Then in the next step, Diels-Alder reaction. Diene is already there. You generated the dienophile. Next step, Diels-Alder reaction. Here a diene plus a dienophile. Simply a 4+2 cycloaddition reaction. 4+2 cycloaddition reaction. So that you get to 1, 2, 3, 4. You can give a number. 1, 2, 3, 4, not 5, 4, 5, 6. A 6-membered ring with a bridged carbon. A 6-membered ring with a bridged carbon. This is the bridged carbon. Between 2 and 3 a pi bond is there. So that's the product. Between 2 and 3 a pi bond is there and that is your product. Then fifth question. A diene is there. Here an OTMS. What is given? An OTMS is given. Plus dienophile is not given. Instead of ScO minus plus pH. A selenium oxide is given. Then condition, first condition, thermal condition, second condition, H plus bar H2O. Okay, diene is there, but there is no dienophile. But this is a selenium oxide and under thermal condition, what type of reaction? pyrolytic syn elimination takes place. So first one, first reaction is EI, pyrolytic syn elimination. So a compound SCPHO minus under thermal condition. What type of reaction? Consider the beta hydrogen. This is alpha carbon, this is beta carbon, and beta carbon containing a hydrogen. This O minus will interact with this hydrogen. This bond will shift toward this side, and this selenium plus is eliminated. Selenium plus is eliminated. So your dienophile is generated. This is your dienophile. This is your dienophile. Okay. Then in the next step, Diels-Alder reaction. Diels-Alder reaction. Diels-Alder reaction. Or the 4+2 cycloaddition reaction. 4+2 cycloaddition reaction. So that you have a diene. A diene is there. This diene containing OTMS. OTMS plus. This is your dienophile. Dienophile can be written like this. In this way. Okay, both are identical. Then what is the reaction? A 4+2 cycloaddition reaction. 4+2 cycloaddition reaction. This bond towards here, this towards here. Here a new sigma bond is formed. So 1, 2, 3, 4, 5, 6. A 6-membered ring is your product. Between this carbon and this carbon a double bond. Here an OTMS group is there. OTMS group. Here a pi bond. Then here the remaining portion of the ring. Remaining portion of the ring. Then one more step is given. One more step is given. Hydrolysis. Hydrolysis of the product. What is the product formed now? A 6-membered ring. Here a pi bond. Here OTMS. OTMS. Then a portion of the 5-membered ring undergo hydrolysis. H plus bar H2O. Here only OTMS is there. Only OTMS is there. So OTMS on hydrolysis converted to OH. OTMS on hydrolysis converted to OH. So this converted to OH and a 5-membered ring. OH and a 5-membered ring. So this is an enol. This is an enol. This enol undergo tautomerism. This enol undergo tautomerism. This enol undergo tautomerism. In the next step, represent the tautomerism. This OH bond to make a pi bond. This will move towards this corner, so that you get a product, a 6-membered ring with a double bond and a 5-membered ring. So that is your final product, a carbonyl compound. Okay, then 6th question. Question number 6. A diene is given. This is the diene OTMS and this is OMe. OMe plus dienophile is not directly given in the question. Instead of a nitrogen oxide is given. Nitrogen oxide NCH3 CH3 O minus plus a nitrogen oxide is given. Then condition, first condition thermal, second condition H plus bar H2O, third condition dibal H under minus 78 degree Celsius. The favorable temperature for diisobutyl aluminum hydride is minus 78 degrees Celsius. Okay. So how you identify that this is a 4+2 cycloaddition reaction? Diene is there, thermal condition is there. The condition for the formation of dienophile is also given. Diene is there, thermal condition is there, and you know nitrogen oxide under thermal condition undergo pyrolytic syn elimination to form a dienophile. An alkene is formed. So in the first step, pyrolytic syn elimination EI. So your nitrogen oxide N CH3 O minus plus, which is the beta hydrogen. This is alpha This is the beta carbon, and beta carbon contains a hydrogen. O minus interact with the beta hydrogen. Here a pi bond is formed. This N plus is eliminated. So that in the first step, an alkene is formed. An alkene. So dienophile is there, diene is also there. So in the second step, not in the second step, dienophile, after dienophile generation, after the generation of dienophile, 4 plus 2 cycloaddition reaction with the already given diene, OTMS, OMe plus the dienophile, the formed dienophile. This is the formed dienophile, a 4 plus 2 cycloaddition reaction. A 4 plus 2 cycloaddition reaction under thermal condition. Okay, so here 1, 2, 3, 4, 5, 6. A 6-membered ring is formed. The product formed is a 6-membered ring is formed. Here an OMe is there, OMe. Here an OTMS is there, OTMS. Here a new pi bond is formed. Then the remaining portion of the ring. So after the cycloaddition step, you get the product. That is the product. First step is 4 plus 2 cycloaddition. A dienophile is generated. After a 4 plus 2 cycloaddition, you get that product. So the product, once again, what is the product? A 6-membered ring. Here a double bond. Here OTMS. Then here OMe is there. OMe. Then remaining portion of the ring. What is the second condition? Second condition is hydrolysis. Hydrolysis. H plus bar H2O. H plus bar H2O. Hydrolysis. What happens? This oxygen containing lone pair. This lone pair will attack the H plus. Lone pair will attack the H plus. So that you get a product. A 6-membered ring. Here a double bond. OTMS. Why OTMS on hydrolysis directly does not undergo OH? Why? Another OMe is there. When OTMS and OMe is there, the H plus will, the lone pair on OMe will attack the H plus. Okay, I already told you that. Okay, you may think that OTMS undergo hydrolysis to form OH. No, that is a product. This OH undergo protonation to form. This OH undergo protonation. Here O, H, Me plus and the remaining portion of the ring. Next step, our H2O is still there. H2O. So H2O undergo SN to attack water molecule, oxygen containing lone pair. SN to attack of silicon. Okay, this bond shift, make a pi bond here. This will move towards this corner. This methanol is eliminated. Methanol is a good leaving group. So methanol is eliminated. So what is the product? A 6-membered ring. Here a double bond O. Double bond O. Here a pi bond. So an alpha beta unsaturated carbonyl compound and the remaining portion of the ring. Remaining portion of the ring. Then in the last step, dibal H. Dibal H under minus 78 degrees Celsius. Dibal H under minus 78 degrees Celsius. You know, when an alpha beta unsaturated carbonyl compound on reaction with the dibal H, the alpha beta unsaturated double bond is not affected. C double bond O group is converted to a secondary alcohol. So what is the product? What is the final product formed? The two ring as such, double bond is not affected. C double bond O is reduced to a secondary alcohol. So an important reaction. First step, 4 concepts are there. First step, pyrolytic syn elimination. Second step, 4 plus 2 cycloaddition reaction. Third step, hydrolysis reaction when both OMe and OTMS are there. Fourth step, reduction using dibal H. Dibal H is a reducing agent which is used for the reduction of cyanide, ester and also alpha beta unsaturated carbonyl compound. So a very important reaction. Then we can move to the next example. Question number 7. Question number 7. A diene is given plus dienophile. Here a CHO is present. Here SC PH O minus. Here also a double bond is there. Condition is thermal condition. First condition thermal. Second condition sodium borohydride is there. NaBH4. What is the product? What is it? What is the reaction? Diene there. Thermal condition there. A dienophile is also there. But the condition for pyrolytic syn elimination. So first of all, pyrolytic syn elimination takes place. I will explain why pyrolytic syn elimination first takes place. You may think that here a diene is there, a dienophile is there. This undergoes for a 4+2 cycloaddition reaction. But before that, pyrolytic syn elimination takes place because so first EI reaction, pyrolytic syn elimination. A 5-membered ring, already a double bond. A CHO is present. Then SC, PH, O minus. Here this is the alpha carbon and this is the beta carbon. Beta carbon containing hydrogen. O minus will interact with the beta hydrogen. This will make a pi bond here. This selenium plus is eliminated. So you get a compound, a 5-membered ring with CHO. Please listen. Which double bond? Double bond A or double bond B is more reactive? Definitely B is more reactive because it is containing an electron withdrawing group CHO. That is why first pyrolytic syn elimination, then only Diels-Alder. If first Diels-Alder reaction takes place, what happens? This double bond does not containing an electron withdrawing ring. Here after pyrolytic elimination, the double bond containing an electron withdrawing ring. So first pyrolytic syn elimination takes place. So your dienophile is ready for the reaction. Then what is the reaction? A 4+2 cycloaddition reaction. So your diene plus dienophile B is reacted. That dienophile containing the CHO group. Okay. Then what about the reaction? Simply a 4+2 cycloaddition reaction. This pi bond is shifted towards here. Here a new sigma bond is formed. So a 6-membered ring is your product. Here a new pi bond. Here a 5-membered ring. And a CHO. Okay. Then reduction using sodium borohydride. What is the function of sodium borohydride? Double bond is not affected, only the reduction of carbonyl compound. But lithium aluminum hydride will reduce both the double bond and carbonyl compound. Sodium borohydride selectively reduce the CHO to a primary alcohol. Aldehyde is reduced to a primary alcohol. Double bond as such, 5-membered ring, CHO is converted to CH2OH. So that is your product. So question number 8. Question number 8. Sorry. A diene is there plus a dienophile. C double bond O, CHO, SC double bond O, pH under thermal condition. What is the reaction? C double bond O, This is a quinone derivative. So a selenium oxide under thermal condition. So first pyrolytic syn elimination takes place. Pyrolytic syn elimination. EI, pyrolytic syn elimination. So this is your generation of dienophile. C double bond O, C double bond O. Here a CHO group is present. Then SC double bond O, pH can be written as SC pH O minus selenium plus. What is the beta hydrogen? This is alpha carbon, beta carbon, and this beta carbon containing a hydrogen. This O minus will interact with the beta hydrogen. This will make a pi bond here. Selenium plus is eliminated. Selenium plus is eliminated under thermal condition. So you will get a product, a quinone derivative, double bond O, CH3, double bond O, not CH3, CHO. CHO, that is your product. Then my question, two double bonds are there. This is the dienophile A, dienophile B. Which is more reactive? B is more reactive because this dienophile containing an electron withdrawing group, so definitely that is more reactive. This is the selectivity of dienophile. Selectivity of dienophile. When two dienophiles are there, which one you will select? That dienophile containing an electron withdrawing group. Okay, then 4+2 cycloaddition reaction, or simply the Diels-Alder reaction with the diene. So in the next step, this diene will react with that more reactive dienophile. This is the more reactive dienophile, that containing the CHO group. Okay, then simply a Diels-Alder reaction, 4+2 cycloaddition reaction under thermal condition. This will move towards there. This here a new sigma bond is formed. So what is the product? A new 6-membered ring is your product. Here a new pi bond. Then C double bond O, C double bond O. Here a CHO is present. CHO. So that's your product. Clear? That's your product. Oh, there also one more double bond is there. So that's your product. Okay, question number 9. Question number 9. N CH3 O minus N plus. N CH3 O minus N plus double bond CHO under thermal condition. Here dienophile is given, but diene is not given. Dienophile is directly given, but diene is not given in the question. Instead of the diene containing two nitrogen oxide, definitely pyrolytic syn elimination takes place. This is the alpha carbon and this is the beta carbon. This beta carbon containing a hydrogen. With respect to this nitrogen oxide, with respect to this one, this is the alpha carbon and this is the beta carbon. This beta carbon contains a hydrogen. So first step is formation of diene. This O minus will interact with this hydrogen. Here a pi bond is formed. This N plus is eliminated. In the next step, this O minus will interact with this hydrogen. Here a pi bond is formed. So N plus is eliminated. So after the elimination of these two groups, you will get a diene like this. Clear? A diene like this is formed. Then this will react with your dienophile CHO under thermal condition, simply a 4+2 cycloaddition reaction. So what is the product? Here CHO group is present. At this position, the CHO group is present. So that is also a 4+2 cycloaddition reaction. Okay. And the last question. Last question. Question number 10. A 6-membered ring OAC plus malic anhydride under thermal condition. Dienophile is there. Malic anhydride is a good dienophile, but diene is not there. Dienophile is there, but diene is not there. So how you can generate the dienophile? This is an ester under thermal condition. Ester under thermal condition. What is the reaction? Ester under thermal condition. Ester is OAC. OAC is C double bond CH3. OAC, this is O C double bond O CH3. Okay, under thermal condition, what happens under thermal condition? This lone pair on oxygen, what is the beta hydrogen? This is alpha, this is beta. This is alpha, one carbon, beta with respect to this is beta carbon containing a hydrogen. Here also beta carbon containing a hydrogen. This lone pair will make a double bond here. This will interact with the beta hydrogen. Here a pi bond is formed. This group is eliminated. Here this C double bond O group, lone pair will make a double bond here. This will interact with the beta hydrogen. Here a pi bond is there. This is eliminated. So in the first step you will generate a diene like this. This is the diene. So a diene is generated, and in the next step on reaction with malic anhydride, double bond O, simply a 4+2 cycloaddition reaction. Finally, what is the product? Here a new sigma bond is formed. New 6-membered ring is formed. Here a pi bond. Remaining portion of the dienophile, double bond O, and that is your final product. Here dienophile there but no diene, but from this pyrolytic elimination of ester you will generate a diene. Then a 4+2 cycloaddition reaction under thermal condition, you will get a product like this. So that's about the coupled question with the pyrolytics in elimination. In the next lecture we will discuss about Diels-Alder reaction followed by pyrolytics in elimination. Okay, so wishing you all the best. Bye.